So welcome to this session. So it seems that you want to get rid of your DBA. Actually, I am a DBA. I'm working as an Oracle DBA for more than 20 years. I've been working in development environment and also operations. And I want to share here my experience and point of view when using microservices in the context of database applications. So I'm Franck Pachot, I'm French, I'm working in Switzerland at CERN. And the agenda here, I will start to talk a bit about what is special with the database for an application, for microservices. From the development point of view, I've heard a lot the database is always a problem. For example, when you want to do continuous integration, it's always difficult with the database. Once you want to deploy, you always have this thing. We will see why the database is always a problem. And then I will show quickly the history of the different software architecture for the software accessing to the database, from monolithic client server to microservices. And then I will have a demo to show you what I call the database burnout. If you do not take care about what you are doing between the application and the database, what can happen? And the goal is to try to build something that is scalable, not just going to microservices as you can do when the database is not involved. So what's special about the database? The problems can be continuous integrations, difficult, single point of failure, many different things that you may think about the database, the fact also that you have to query with SQL. Actually, I think that all those problems come from three properties of the database. It's shared, it's persistent, and you query it with SQL. So we will look at them. Shared means that on a database you have multiple users at the same time and doing different things. That means that the database is not optimized just for one kind of query, one use case. You have multiple different users, some doing some transactional processing, some doing some analytics. And at the same time means concurrency, logs, performance bottlenecks. The fact that the database is shared, the data is shared, that's a good reason to have one central database to share with everybody, because if you want many smaller databases, you will have to think about replication, keep the thing consistent, so that's difficult. So the fact that the database is shared can be a problem in production, but also for development. You may prefer to have all your developers accessing the same development database. That's a good way to see very early if there is a problem between two different parts of the code. You may also today, within clones of databases, you may also give one database to each developer, but then you may see the integration problem a bit too late. So all this because it's shared, one database shared. And then you have this idea of microservices. Instead of one shared by everybody, maybe smaller databases shared by less people. And also the main point there is that each smaller database for each microservice, sorry, that's blocked. Okay, we will have a blue point in the middle. Don't know why, sorry. The mouse, no. Okay, so with microservices, the goal would be that each little database has an owner. And if you want to change a structure, you have only one person or one team who knows exactly the side effects that you can have with that. So that's good. That's easy if those services do not share any data. That happens. If they share some data, you may accept some asynchronous replicas with consistency or eventual consistency. Or maybe all those services will have to communicate through APIs to exchange the data. And problems can come from that. The blue point is gone. Okay. While talking about this, this is a diagram I did at a customer, so not microservices, just a few databases, one for the CRM, one for the ERP. And because of a migration project, I had to look at the database links. And this was the cartography of database links, a big plate of spaghetti. If those people want to go to microservices and get even smaller databases, that will be just impossible. So it's possible to divide in smaller databases if each service will be loosely coupled and no cyclical dependency. If you have a cyclical dependency and you need to restart a database, for example, you don't know which one you will start at the beginning. So be careful with that. If you already did wrong within a monolithic database with all links and everything, that will be worse if you go to microservices. So the second property, persistency, of course, for the database, that's different from the application. Your application code, your application server, you can stop it, restart it, start it in 100 of servers, because there is nothing persistent. For the data, that's different, and that's also the reason why it's easier to have one central database. Also, you may think about the backups. If you put everything in one database, like in monolithic architectures, you just back up the database, and you have also most of the code in it. And if you need to restore something in 10 years for legal reasons, you have everything. If you split that to 10 microservices, different technologies, then in 10 years, are you able to restore the data and have the code to access them? That can be difficult also. So this is also why in microservices, where the database is important, you may choose the CQRS architecture, command query. Oh, I will stop with that. Sorry. Command, the segregation between the queries, just read-only, and the modifications, so that you have only one service modifying the data. What you query, you can have different replicas. So those are just ideas, but you need consistency also, and that's quite difficult. I said that it can be difficult if for legal reason you have to keep backups. That's even worse if you have some services storing their data as non-structured data, because the non-structured data without the code to read it has no meaning. So instead of backupping only one database, you may have to backup 10 different databases, different technology, and the code and the version of the code to access it. That can be difficult from an operational point of view. And the third property, SQL. You access the database with SQL, most of the databases. SQL is a very powerful language. It's an old language, it's still there. It's the only fourth generation language that is still there. Most of the procedural languages are third generation languages. So that's nice, but probably that's too complex for most of the development team today. And this is why a lot of developments just go back to what was before SQL. So procedural languages instead of the declarative language SQL, and also they go back to hierarchical structures that were there before the relational databases like XML, JSON, etc. And because of the complexity of SQL and the fact that it's not really portable, there is a standard, but the standard is just about the syntax and some behavior. But if you develop some SQL application for Oracle and you want to move to something else, that can be difficult. It's even worse if you need some procedural language, PL/SQL for Oracle, and you want to migrate that. If you build an Apex application with Oracle, that will be difficult to migrate. So that's the problem people see with SQL. And also SQL developers, because it's complex, SQL developers are quite expensive. PL SQL developers even more because it's rare. And that's the reason why in software development, they don't want to use SQL anymore or PL SQL just because it's cheaper to find a lot of young developers doing JavaScript, Python, or anything. So the idea of microservices, maybe you take a service and this one can be developed offshore, developed by a young developer. So those are the three properties, and so just to look at the history, monolithic servers, so that was before, at the mainframe time maybe, where everything was in the database, the code and the database, the application and the database, and only the presentation layer, very small, was not there. This was very difficult to maintain because you have only one. And then this is where came the client server, just putting all the business logic out of the database for the reason we have seen. The problem with that was that then all the code must be deployed everywhere, so that was not really good, and this is why we came to the three-tier architecture, where you have one big database. It's more like this, one big database, one, two, multiple application servers, because those one you can distribute them on different nodes, and a lot of presentation layer then. But you still have one database, and the idea of the microservices may be to split all that, smaller components. Before going beyond, because I will explain that the problem is the communication between them, I have a demo to show you where I will build a very simple service, and we will see how it behaves when I run the procedural language only in the database or only on the application side. So let me share my demo screen. Here it is. I'm there. Is it okay? The screen is quite small. I don't know if we can reduce a bit the light, but you can also move in front if it's difficult. So the idea here, I have split my screen. This is top, because we will look at the CPU consumption when we are doing those things. And on the top, I will just connect, so I'm doing my demos with a NoSQL database and SQL.cl as the client for it. And I will just create a user, create a customers table, and an account table. The idea is that I will just build a service that is doing transferring an amount from one account to another account. So this is the create table for customer accounts. I insert some data in them, 5,000 customers, and in accounts, I just insert 100 per customer, which means 500,000 accounts. Here they are. They all have their amount at 10,000. And so this is the data, average 10,000. And this is basically what the procedure I want to create. I will start to create it in a PL SQL just because that's easy to read. Let me go through and I show you. So I just create a procedure called transfer, where I pass the account to debit, the account to credit, and the amount. And here it's just an update of the first account to decrease the amount, and an update of the second one to increase the amount. So something very simple. I just test it. If I transfer $10 from the account 1 to 2, we can see the result. Okay, I just roll back to get back to the beginning, and before running my procedure, I will do the same with SQL only. My goal is that all the accounts except the first one will give $10 to the first one. So I will call my procedure several times, but before that, I will just run SQL as if I only want to do things in the database with SQL. I have a little script that captures the CPU consumption. We will see in real time with top, and at the end we will see the number of seconds of CPUs. Everything is in cache, there is no I/O. I'm just looking at the CPU consumption here. So in two SQL statements, moving $1 from all the accounts to the first one, I can do that with two updates. All the accounts except the first one will have the amount decreased by 1, and all the others, so I count just to get them, give $1. So two updates. To do what I wanted, everybody gives $1 to the first one. 7 seconds of CPU, so that's fast. This is the result just to check that it is okay. So that's very fast, that's very okay. The problem is maintaining the code. I have two SQL statements, but there is no business logic of it. It's not a procedure called transfer, just the statement built for a specific usage. I roll back because I will do the same different time. The rollback is approximately the same time because it changes to the previous value, so that's 5 seconds. If I want to do that in only one SQL statement, one service is one SQL statement, I can also do that. I go quickly to it. This is just an update where I check if it's account 1, then I increase. If it's not, I decrease. So I can implement a service with only one SQL, but that's very difficult to maintain. If I had more business rules, such as taking fees on each amount, if the SQL can grow, and that will be impossible to maintain. But just to show you, it's about the same 6 seconds of CPUs. And now I get back to my procedure that I've created. So let's roll back just the data, and this is the described of my procedure and the procedure we have seen. So now I will call it in a loop for each account. This is easier to read. It's called transfer. It transfers from one account to the other, and then I call it for each account. That's easier to read and to maintain. So I run it. I have here a loop on all accounts more than one. I transfer from that account to the first one. You can see the CPU usage. This is the process of my Oracle session. My Oracle database is called DBML. You will see later why. And all this is running in the database. It's PL SQL running in the database, doing exactly the same thing as we did before in 5 seconds. And it took 30 seconds here. To do exactly the same work, 30 seconds of CPU, same result. If I roll back the same work, and this takes just few seconds as before. It was long with my procedure because PL SQL is running in a different engine than SQL. On the same process, we have seen 100% CPU on that process, but it's a different engine, and when you have different engine, each round trip between them have a switch of context, passing data types, anything, and that takes time, CPU time. Not to do the important work, updating the data, just to communicate. But you have to balance that with the fact that the procedure is much easier to read, to maintain, than raw SQL statements. So I said that PL SQL, expensive developers, people do not want that because of vendor locking. If you build your application in PL SQL and Oracle decides that the core factor is more expensive, then that will be difficult to go to another database. So maybe you want to run in a different language. And currently, Running in the database, it's only SQL or PL/SQL. If you want to run in a different language, you will run it on the client. And here, I will do it from SQL Developer because it's Java. I can run JavaScript. I will do the same with JavaScript. This is just the setup of the connection. Just checking the numbers, nothing very important, just to be sure that I am in the same state. And this is my service. So a JavaScript function called transfer, which will call those two statements that were prepared before. Transferring from account 1 to account 2, the same updates. So basically the same idea, but in JavaScript. And I will call that, there is a loop where I will call that for all the accounts. So doing exactly the same thing as the PL/SQL did, but from JavaScript running in the client. And we will run that. So now you can see that I have two processes active here. Java, that's my client, and Oracle DBML, that's what happens on the database. Here I am in the same machine, the same server. Usually you have that in different nodes. And you see that the total is nearly 100%. The work is divided between both of them. They cannot work at the same time because one is asking something to the other and waits. So that's difficult to scale. And you can see that it takes long. So while it is running, I will just explain what is very different from there. Before, in SQL, we were in only one engine. PL/SQL calling SQL, we were in two engines implemented in the same executable. Different library, but compiled and linked together to run in the same process. So some context switch between PL/SQL and SQL, but within the same process. Here, we are in completely different processes. So even the OS has to switch the context between them. Java is calling some update, which means that the Java process goes out of the CPU, and then the Oracle process will come running in the CPU, and that's context switches, and then when the result is there, goes back. All that time in the communication and the switch between those two processes, and we can see that it is even longer than the PL/SQL thing. I will continue in the slide if it's too long, but no, okay. So 2 minutes of elapsed time here. And you can see part of it in the database and part of it in the client. And that's a lot. The Java is doing nothing except loops and calls. No real work. And that takes time, and it's not idle time, it's CPU time. Something interesting also, remember, the real time to change the thing, to do the modification in the database is about 5 seconds. Here, I offload part of it to JavaScript. But offloading that from the database, finally, uses more CPU in the database. If you think that you put everything out of the database just because you don't want to use the database CPUs that are expensive, you pay licenses per core, finally, you use more CPU just because the database has less work to do, but more work to receive the calls and set the context to process it and get back. So that's important to know also. And the last thing I will show you, just doing the rollback to get in the same state. So that was longer because it was not running in the database. PL/SQL was faster, but it's only PL/SQL. Actually, here I can run JavaScript within the database. My instance is called DBML. It's the beta version of Oracle database multilingual engine. They are currently building something, an engine that can run many languages within the database without all those switch of context. The beta was out at last Open World. There will be a new beta announced probably this week. This beta has only JavaScript. The new beta that will come in a week will also be able to run Python. So in theory, they can run any language. They implement the language that are in the trend. So let's run that. I declare my function. Only the call to SQL are a bit different, but that's the idea. I declare a function in JavaScript. And I declare it in TypeScript, and I deploy it within the database. In this beta, we have a tool, DBGS, that deploys the JavaScript code within the database. I connect, and if I select from user libraries, I can see this library, JavaScript. So this cannot be done today in production. This is a beta version. If it is out, it may be out in 2 or 3 years. Here it is, and I will call it. So I'm running JavaScript, and you can see only one process active, the database process. So I still have a switch between SQL and JavaScript, but within one engine, the multilingual engine, and within one process. That can be an alternative if, for performance reasons, for what we have seen, you want to put some logic in the database, but you do not want to code in PL/SQL. The idea when they will have that in the database in general availability, the idea is that you have a library in JavaScript, and you can run it in the client in the database where you want without really caring about where it is. Their plan is to implement that in Oracle database and also in MySQL. I don't know if it will be free. Huh? So here it is. You see the time. Everything is longer than doing directly the SQL. But you can compare the time with PL/SQL. Remember, it's a beta, so there are some things that may be longer because they may add some checks, and there may be some optimization. If it works, they have also the idea, maybe one day, to move the PL/SQL execution within that multilingual engine. And you can combine everything, have JavaScript calling Python, calling PL/SQL, and have fun with that. Okay, so that was a demo just to talk about context switches. Let me check the time. Perfect. So this is a summary of the time. We have seen mostly the same here. I explained that context switch between two engines and between two processes. It can be even worse. Here I was on the same server. If you put the application, the JavaScript in another server, then you have network round trip in it. If you go through a JBoss connection pool, which does a select star from dual for each call, you will even double the work done there. So think about it. Because I'm working at CERN, I have just a slide to show you. Context switch is fast. You have here a link to a website which details the time it takes in CPU cycles for different operations. And the switch of context is there. It's something that is fast. But as an example, at CERN, the accelerator is 27 kilometers round. And during one context switch, the protons running near the speed of the light can do only one turn. So it's fast, a context switch, but if you look at the physics, what is happening in the CPU, very long operation when you compare it to the real work that is done. So this is our diagram about microservices, and what I wanted to show you is that you may have a lot of round trip between all those components. Here, the boxes are physical components. Different engine, different process, different server, and you have a lot of interaction, which means that maybe when going to microservices, you will have to reduce some of those interactions. Here, what I did, I still have two components, to maintain, but I run them in the same engine, exactly like a JavaScript function running in the database. It's important to separate what we want to do logically, separate things, to manage them easily, but physically, it's important to be able to collocate them. And maybe even share physically some of the data just to reduce the interaction and keep only what is loosely coupled between the services. I mean, it's important to go microservices. Just remember that the microservice architecture is not there to address performance or scalability. It is there to address an organizational problem for development. To manage smaller things, it's easier. But for performance, physically, in the physical model, it's better to have things in the same engine. And then there are two ideas when going to microservices to keep in mind about the database. If you have data that is not shared, used by only one service, then you can have an embedded database. Do not call a database elsewhere if you do not need to share the data. You can have MongoDB, you can have NoSQL databases embedded, so you put the database to the code. If you need more interaction between them, you may have to do the opposite. Put the code to the database. And remember that even if you put everything in the database, you can keep the logical separation. In database, we have packages, we have views, we have schemas, we have everything to be able to segregate a schema, having a development team dedicated, anything. Of course, you can also build packages that call everything everywhere. But the logical separation, you can also do it within the database. Currently, SQL, PL/SQL views, so you have to learn that. And maybe in the future with some other languages, Python or multi-language. So those are the two ways, some data with the code or some code with the data. And so as conclusion on that, very important, what I want to say here is PowerPoint is very different from the physical implementation. Unfortunately, I've seen a lot of software architects who work only on Wikipedia, PowerPoint, and whiteboard. And there, it's very good to separate and draw boxes because it's easier to understand and to maintain. But I've seen people saying that today you do not need to move from the logical model to the physical model. But that's wrong, because finally it works on a physical model, on an implementation, where you have laws of physics where it takes time to switch between the others. So good to go to a logical model, very clear with separation. But for the implementation, maybe look at the solution where you can have those things working together without bottlenecks. So embedded databases or shared database. Okay, what time is it? So before some questions maybe, just to tell you that we are, so those are the two other sessions I do at this conference. Maybe you don't know, here we are in Moscone West, you have some session in Moscone South, and there is also, if you are interested in the database, IT and more technical things, there is the Octable conference, maybe not easy to find, behind the carousel there, you go there, you will see Octable, and you can go to the website. It's not commercial. It's really some people doing a conference within a conference with more technical things. Can be interesting. Do you have some question about that? First, can I get an idea who is working with an Oracle database and who is working with something non-Oracle here? Just because it's the first time I present at Oracle Code One or anything, so I didn't know if it's mostly Oracle customers. So a lot of you are working with something else. This is something that we see today. People want to choose the technology, choose the language, not be forced to use one database, one language. Do you have questions? Yeah.
Relating to physical co-location, I understand from the microservices point of view, the developers write great code and no issue, and it can process within few seconds. So you want to have this co-location to avoid the context switches, and that could be to optimize the performance. But performance issues can arise from different issues, right? Like as a DBA, you probably knew that. If a developer writes a bad code, and if you have couple of bad codes running, and it takes minutes, and pretty soon you see all kinds of wait events happening on the database layer, right? The concurrency related things. So I think this is very informative, and it's very useful from the context check, context switch perspective to avoid those kind of wait events. But they could be other problems you're introducing if you're talking about like having one database.
Yeah, sure. But if you have wait events, you will have switch of context because each wait event will be a system call. So you may have more problem. Of course, if you switch the context and have to do a physical I/O, that will be worse. But even if you optimize everything that is behind the wait event, for example, you have a physical I/O and you get it from cache, but the switch of context is always there. But of course, you may have all other problems. Here, my goal was just to show that you may introduce more problems than solving them if you do it not in the correct way. But that's, yeah, I totally agree with what you say there. Okay, any question? Yeah?
You showed two first examples, though, with the 5 seconds and the 30 seconds, right? The first one is probably one transaction. And the other one
Yeah. All those were only one transaction I committed at the end. If my transfer service was committing, which would be better? A transfer service would commit or roll back each one. It would be worse. Here, I just didn't commit just to be able to roll back and show anything else. But if you are doing things in bulk with one update because you have to do a lot of transfers, then you commit at the end. But if you build a transfer service, this service will commit for each transfer. So that can be worse.
That's what I was thinking about, because if you have microservices doing individual things, you will commit every change, right?
Yeah.
For big data manipulation.
Even more contention. Yeah. This is just the small contention that people do not always see, but this is what you are saying and what was said before. You may introduce even more problems. Sure. Doing things in bulk in a database is the way to keep things scalable. Yeah. But I can understand that from a development point of view, that's difficult to maintain big SQL statements and dedicated. I mean, if I do that only with SQL, that's optimized. But then I will have a service for individual transfer. I will have a service for bulk transfer. All that to maintain doing the same business thing. So, okay. So thank you very much.